How to write code for deletion in linked list. In the last lecture, we learned how to delete a node from a linked list. Here, we are going to see how to implement whatever we learned in the last lecture. That is, if you want to delete a node from a linked list, how to write a code which will delete it for you. What did we learn in the last lecture? We learned that if you want to delete any node from a linked list, you should start traversing from the first node and keep traversing till you reach one position before your target position. Whatever be the position you want to delete from, stop your traversal one position before that. And then you have to adjust the next pointer of this node such that it will skip one node in the linked list. This is the logic. Let us see how to write a function code such that it will do this deletion for you. We'll call this as delete. The function is called delete. What should it have as arguments? One is it should know which is the linked list from which you want to delete. That is, it should have a reference to this linked list. Reference is the head pointer of your linked list. What is the other thing? It should also know which is the position at which you want to do deletion. We'll call it as position. Two things. One is the head pointer which will tell you which is the linked list, and position which will tell you which is the position from which you want to delete. What is the first step? In the last lecture, we learned that always whenever you want to delete, the first step is to make sure that your linked list is having some element. If it is an empty list, you can't do any deletion. So what should you do? You have to check whether the list is empty. We also learned that for that you have to check whether head pointer is null. So if your head pointer is null, how can you check if head pointer is null? You can simply write if not head. That means if head is null, what should you do? You can't do anything here. It is an empty list. Simply return null or return the head pointer because there is nothing to be deleted. What is the other case? Let us consider that there is something in the linked list. In case this return is not hit, that means it didn't enter this if condition. So there is something in the linked list. We can go forward with deletion. In deletion, there were three cases that we learned. One is in deletion at the beginning, then deletion at the end, and at any specific position. We are going to write code by combining all these, but deletion at beginning should still be considered as a special case. What should you do for that? The reason is you have to stop at the node before the node you want to delete. If you want to delete beginning node, that is the first node, where will you stop? So this has to be a special case. What will you do this? Whatever we learned for deletion at beginning in the previous lecture. If position equal to 0, position equal to 0 means position to be deleted as a beginning position. What should you do? First thing, you should have a temporary pointer, your temp pointer, which will keep track of the node to be deleted. Here it is the first node, so temp is equal to head. This will mean your temporary pointer is now pointing to the head node, that is the first node of the linked list. After that, what should you do? You should make your head pointer to the next node. Head should now point to next node so that first node is no more part of your linked list. What will you do? Your head, you will make this head pointing next. When you make head is equal to head pointing next, your first node, that is this will be the first node pointed by head. If you make your head pointer as head pointing next instead of this, first node is no more a part of your linked list. That is what we did here. After this, what can we do? You have to free whatever is pointed by your temp pointer. That is your deleted node. That should be freed. And then you can return your head pointer. Why are you always returning head pointer? Because head pointer is what references a linked list. It is the identity of a linked list. If you want to pass a linked list somewhere, you will always pass the head pointer. Given that this condition is also not met, what can you say? The position is not beginning position. Considering that these two conditions are not met, that is, linked list is not empty and the position to be deleted is not the beginning position, then what can you do? You have to consider that the position is either somewhere in the middle or it is the last position. Both these cases can be considered together. For this, what can we do? You have to say current is equal to head pointer. This is where we are starting the traversal. And you will have index is equal to 0. Using this index, we will keep track of the position. Why are we keeping track of the position? The reason is we should know whenever we reach the position which is just before the position to be deleted. For this, we will keep track of index. Whenever you reach the position just before the position to be deleted, you should stop traversal there. This current pointer, this is the pointer using which you will traverse through the linked list. Okay. Initially, it will be at the head. That is the first node of the linked list. What should you do now? You should keep traversing using a while loop. I'll have a while loop. What should be the condition inside this while loop? In this while loop, first condition is that current should be a valid node. Whatever current is pointing to, it should not be null. If it is null, that means you already reached the end of your linked list. You can't delete. Whatever position is provided is an invalid position. Otherwise, in case current is valid, then you should also see if your index is lesser than position minus 1. What is this condition? This means whenever you are at a position which is just before your target position, then you should stop your traversal. That is why we are having position minus 1 here. What should you do in this loop? In this loop, every time you enter the loop, you should proceed to the next node that is in the linked list. How will you do that? For that, you will do current is equal to current pointing next. That is, wherever you are standing, you will move the current pointer to the next node. This is what you are doing. Along with this, you have to increment index so that you can keep track of position. That is why you will do index is equal to index plus 1. Whenever this index reaches position minus 1, that is when you want to exit this loop. That is this condition. Whenever you came out of the loop, what does it mean? It means either your current is null. If your current is null, that means the position is invalid. You can't delete from that position because you already moved past the end of your list. That is why your current is null. Otherwise, there is one more thing to be checked. That is, if your current pointing next is null. In case of deletion, we told that whichever be the node you want to delete, you are going to stop at the node which is before that. So if your current pointing next is null, then also there is nothing to delete because your next one is the one you are trying to delete, and if your current pointing next is null, there is nothing to be deleted. So in both those cases, the position that is provided is invalid. You can't do any deletion at this point. What should you do then? If two cases, one is if current is null, if not current, or what is the other case? Other cases, if current pointing next is null, that is not current pointing next. If either current or current pointing next is null, then what should you do? You should say this is an invalid position. You should simply return the head pointer. You can't do any deletion because whatever is the position provided, that is invalid position. Once it crosses this point, you know that you are pointing with your current pointer to a valid position. There is a node which is existing right after the current pointer, which is pointed by current pointing next, and this is the node to be deleted. This much is clear. What will you do now? You have to proceed with deletion. For that, what is the procedure? First, you have to keep a temporary pointer. What will this temporary pointer do? Temporary pointer will point to current pointing next. Why is it pointing to current pointing next? Because current is the position before the position to be deleted. So current pointing next will point to whichever is the actual node to be deleted. That is what you have to keep track of temporary pointer. That is why temp is pointing to current pointing next. After this, what should you do? Your current pointing next, what should it point to now? It should point past this node to the next one. For that, you want to make current pointing next, that is whichever is the next pointer of current, this should point to temp pointing next, because temp is your node to be deleted, whichever is the next one. This is what current pointing next should point to. You can either write this as current pointing next equal to temp pointing next, or you can also write this as current pointing next is equal to current pointing next pointing next. That is also valid. Either of the notations is valid. Whichever you feel more comfortable, you can use that. Either it should be current pointing next is equal to temp pointing next, or you can write current pointing next is equal to current pointing next pointing next. Both are the same thing because temp itself is current pointing next. That is the reason. At this point, it is as good as not having this node because you already made this next point to skip one particular node. Next step is you have to free whatever is present in the temp. This will free the memory that is used up by this particular node. After this, your procedure is completed. You can return head. This is the algorithm. Let us just go through this once more so that it stays clear for you. Initially, what did we do? Initially, we had two parameters, head and position. If the list is null, list is empty, what did we do? We simply return the head pointer, which is null, because there is no deletion possible if there is no element at all in the list. Next thing is, in case the position is 0, that is you want to delete from the beginning, then what should you do? You should make head pointer point to head pointing next, and after that you should remove whichever was the previous first node. What is the other case? In case you want to delete any of the intermediate nodes or the last node, for that you have to traverse till the position that is one position lesser than the position of target node. For that we are having a while loop using which we reached the right position. Then you have to verify that the position is valid. For that you will check whether current is null or if current pointing next is null. Either of the cases, the position provided is an invalid position. You cannot do deletion. In case it is valid position, then what will you do? Then you will make a temporary pointer which will point to current pointing next, which is the position of deletion. Then you will make current pointing next point to temp pointing next or current pointing next. After this, you can free the temporary variable, that is whichever was pointed by the temporary pointer, that particular node will now be freed. This is the end of the procedure. You can return head. This is how you do deletion in a linked list. What is the time complexity of this procedure? In the worst case, the position will be the end position. You have to traverse from the first position till the end of the linked list, because of which time complexity is order of n. And what about the space complexity? You are not using any additional space for deletion and your space complexity is order of 1.